Wiring a heat lamp with a thermostat and a switch in parallel can be achieved effectively. Let's examine the operation. In normal operation, the thermostat will activate the heat lamp if the temperature drops below the set point. This ensures that the well house maintains a minimum temperature to prevent freezing. There is a switch override function. The switch provides a manual override, allowing the heat lamp to be turned on or off regardless of the thermostat setting. This is useful for maintenance or when supplemental heat is required. When both the thermostat and the switch are on simultaneously, the heat lamp will remain on. Both devices are supplying power to the heat lamp in parallel, so the lamp operates as long as either is active. Now, addressing potential code violations. Wiring switches in parallel like this does not violate electrical codes. This configuration is a standard practice for controlling lights or devices from multiple locations. Wiring switches in parallel essentially creates redundancy. As long as either switch is closed, the circuit is completed and power flows to the load, in this case, the heat lamp. Let's talk more about the components. The thermostat should be rated for the voltage and amperage of the heat lamp. The switch must also be rated appropriately. Typically, a standard 15 amp or 20 amp rated switch will suffice for most heat lamps. The wiring itself must be of the correct gauge. The gauge will depend on the amperage draw of the heat lamp and the length of the wire run. Consult the National Electrical Code, NEC, Table 310.15 for proper wire sizing. Now for the wiring connections. Ensure all connections are secure. Use wire connectors or solder and tape to prevent loose connections, which can cause overheating or arcing. It is important to ground the heat lamp properly. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Using a grounded receptacle and ensuring the heat lamp has a grounding conductor is essential. When installing the wiring in a well house, consider the environment. Well houses can be damp or wet environments. Use weatherproof enclosures and fittings to protect the wiring and devices from moisture. Ground fault circuit interrupter (GFCI) protection is also recommended for receptacles in damp locations. Now let's consider alternative wiring configurations. While wiring the thermostat and switch in parallel is acceptable, other configurations could offer different functionalities. For instance, a series configuration could be used, but it would require both the thermostat and the switch to be closed for the heat lamp to operate, which isn't the desired behavior in this scenario. Another aspect to consider is energy efficiency. If the heat lamp runs continuously due to the switch being left on, it will consume more energy than if it were controlled solely by the thermostat. Therefore, it is important to use the switch judiciously. Consider adding an indicator light in parallel with the heat lamp to indicate when it is on. This can serve as a reminder to turn off the switch when the additional heat is no longer needed. When troubleshooting the circuit, if the heat lamp does not turn on when either the thermostat or the switch is activated, first check the circuit breaker. If the breaker is tripped, reset it and observe if it trips again. If it trips repeatedly, there may be a short circuit in the wiring or a fault in the heat lamp itself. If the breaker is not tripped, use a multimeter to check for voltage at the heat lamp socket. If there is no voltage, trace the wiring back to the switch and thermostat to identify the point of failure. Remember to always disconnect the power before working on any electrical circuits. Safety is paramount. Wear appropriate personal protective equipment, PPE, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, consult a qualified electrician. For the thermostat selection, choose a thermostat that is specifically designed for the intended application. Some thermostats are designed for heating applications, while others are designed for cooling applications. Make sure the thermostat has the appropriate temperature range and sensitivity for the wellhouse environment. Electronic thermostats offer more precise temperature control than mechanical thermostats. This can lead to improved energy efficiency and more consistent temperature maintenance. If using an electronic thermostat, ensure it is compatible with the voltage and amperage requirements of the heat lamp. When selecting a switch, consider the type of switch. A standard toggle switch is commonly used for this application. However, other types of switches, such as rocker switches or dimmer switches, could be used depending on the desired functionality. A dimmer switch would allow you to adjust the intensity of the heat lamp, providing more control over the heat output. However, ensure the heat lamp is compatible with dimmer switches before using one. Now, considering the location of the well house in Maryland, it is important to take into account the local climate conditions. Maryland experiences cold winters, so the heat lamp needs to be adequately sized to provide sufficient heat to prevent freezing. The thermostat set point should be adjusted based on the typical winter temperatures in the area. Monitoring the temperature inside the well house with a thermometer can help to fine-tune the thermostat setting. Regular maintenance of the heat lamp and wiring is important. Check the wiring for any signs of damage such as cracks or frayed insulation. Replace any damaged wiring immediately. Clean the heat lamp reflector regularly to maintain optimal heat output. Check the thermostat and switch for proper operation. Replace them if they are not functioning correctly. Consider using a smart thermostat to remotely monitor and control the temperature in the well house. Smart thermostats can be programmed with custom schedules and can send alerts if the temperature drops below a certain level. This can provide added peace of mind, especially during periods of extreme cold. A heat lamp should be positioned in a location where it will not come into contact with any flammable materials. Keep the area around the heat lamp clear of debris. Consider installing a wire guard around the heat lamp to prevent accidental contact. If the heat lamp uses a bulb, use the correct wattage bulb for the fixture. Using a bulb with a higher wattage than the fixture is rated for can cause overheating and potentially a fire hazard. Also, ensure the bulb is securely screwed into the socket. A loose bulb can cause arcing and overheating. When running the wiring to the well house, use appropriate conduit to protect the wires from physical damage. Conduit can be made of metal or plastic. The type of conduit used will depend on the specific application and local codes. Bury the conduit at a sufficient depth to protect it from damage from digging or other activities. When connecting the wiring to the main electrical panel, make sure to use the correct size circuit breaker. The circuit breaker should be sized to protect the wiring and the heat lamp from overcurrent. Consult the NEC table 240.4 for proper circuit breaker sizing. Now, for the electrical panel connections, ensure all connections are tight and secure. Use a torque wrench to tighten the connections to the specified torque value. Loose connections can cause overheating and arcing, which can lead to a fire hazard. Label the circuit breaker clearly so that it can be easily identified in the future. This will be helpful for troubleshooting and maintenance. Inspect the wiring regularly for any signs of corrosion. Corrosion can occur in damp or wet environment. If corrosion is present, clean the affected area and apply corrosion inhibitor. Replace any wiring that is severely corroded. If the well house is located in an area that is prone to lightning strikes, consider installing a surge protector to protect the heat lamp and other electrical equipment from damage. Surge protectors divert excess voltage to ground, preventing it from damaging sensitive electronic components. Also, ensure the well house is properly grounded. Grounding helps to protect against electrical shock and damage from lightning strikes. The grounding system should be inspected regularly to ensure it is in good condition. If the well house has a metal roof or siding, make sure it is properly bonded to the grounding system. This helps to prevent electrical shock if the roof or siding becomes energized. Now let's talk about documentation. Keep a record of all wiring and electrical work performed in the well house. This documentation should include a wiring diagram, a list of materials used, and the date the work was performed. This documentation will be helpful for future troubleshooting and maintenance. Store the documentation in a safe and accessible location. When making any changes to the electrical system in the well house, make sure to update the documentation accordingly. Finally, safety is important. Always follow safe electrical practices when working with electricity. If you are not comfortable working with electricity, consult a qualified electrician. The NEC provides detailed guidelines for safe electrical installations. Follow the NEC guidelines carefully to ensure a safe and reliable electrical system. Be aware of the potential hazards of working with electricity, such as electrical shock and arc flash. Take precautions to protect yourself from these hazards. Wear appropriate PPE, such as safety glasses, insulated gloves, and insulated clothing. Work in a well-lit area and avoid working in damp or wet conditions. Now, concerning the heat lamp, it should be specifically designed for outdoor use. Outdoor-rated heat lamps are designed to withstand the elements and are less likely to corrode or fail prematurely. Consider using a heat lamp with a built-in thermostat and over-temperature protection. This will provide added safety and convenience. Some heat lamps have adjustable thermostats, which allow you to fine-tune the temperature setting. If the heat lamp uses a heating element, check the element regularly for any signs of damage. Replace the element if it is damaged. Also, when replacing the heating element, make sure to use the correct replacement part. Using the wrong replacement part can damage the heat lamp or create a safety hazard. The location of the well house in Maryland is subject to varying humidity levels throughout the year. High humidity can accelerate corrosion of electrical components. Therefore, it is important to take steps to protect the electrical system from moisture. Use moisture-resistant wiring and connectors. Apply a corrosion inhibitor to exposed metal surfaces. Ensure the well house is properly ventilated to prevent the buildup of moisture. Now, for ventilation. Adequate ventilation can help to prevent condensation, which can lead to corrosion and electrical problems. Consider installing a vent fan to improve ventilation in the well house. The vent fan should be sized appropriately for the size of the well house. Consider using a dehumidifier to reduce the humidity level in the well house. A dehumidifier can help to prevent condensation and corrosion. If you are using a dehumidifier, make sure to empty the water collection container regularly. During periods of heavy rain or snow, check the well house regularly for leaks. Repair any leaks promptly to prevent water damage. Water can damage electrical components and create a safety hazard. If the well house is located in a flood-prone area, consider elevating the electrical equipment to protect it from flood damage. Elevating the equipment can help to prevent damage and electrical shock. Consult with a qualified electrician or building contractor to determine the best way to elevate the equipment. Also, inspect the area around the well house regularly for any potential hazards, such as fallen trees or branches. Remove any hazards promptly to prevent damage to the well house and the electrical system. When performing any maintenance or repairs on the electrical system, always disconnect the power first. This will help to prevent electrical shock. Double-check that the power is off before starting any work. Use a voltage tester to verify that the circuit is de-energized. Follow lockout-tagout procedures to prevent the power from being accidentally turned back on while you are working. If you are not familiar with lockout-tagout procedures, consult with a qualified electrician or safety professional. Do not work alone when performing electrical work. Have someone nearby who can assist you in case of an emergency. Make sure your assistant knows how to shut off the power in case of an emergency. Keep a first aid kit readily available in case of an injury. Know the location of the nearest medical facility in case of a serious injury. Report any electrical hazards or unsafe conditions to the appropriate authorities. Following these guidelines will help to ensure a safe and reliable electrical system in your well house. Always prioritize safety when working with electricity. Now let's address some common misconceptions about wiring switches in parallel. One misconception is that it increases the voltage to the load. Wiring switches in parallel does not increase the voltage. The voltage remains the same. Wiring switches in parallel simply provides multiple paths for the current to flow to the load. Another misconception is that it increases the current to the load. Wiring switches in parallel does not increase the current unless the load is specifically designed to draw more current when multiple switches are closed. In most cases, the current remains the same regardless of how many switches are closed. A third misconception is that it creates a short circuit. Wiring switches in parallel does not create a short circuit as long as the switches are properly wired and the load is not faulty. The switches simply provide alternative paths for the current to flow. Now let's explore some advanced wiring techniques. One technique is to use a three-way switch configuration. A three-way switch configuration allows you to control the heat lamp from two different locations. This can be useful if you want to be able to turn the heat lamp on or off from inside the house and from outside the well house. Another technique is to use a programmable logic controller (PLC). A PLC can be used to automate the operation of the heat lamp based on various factors, such as temperature, time of day, or occupancy. A PLC can provide more sophisticated control over the heat lamp than a simple thermostat. A third technique is to use a wireless remote control system. A wireless remote control system allows you to control the heat lamp from a distance. This can be useful if you want to be able to turn the heat lamp on or off without having to go to the well house. Now let's talk about energy conservation. One way to conserve energy is to use an energy-efficient heat lamp. Energy-efficient heat lamps use less energy to produce the same amount of heat as standard heat lamps. Another way to conserve energy is to use a timer to control the heat lamp. A timer can be programmed to turn the heat lamp on and off at specific times of day. This can help to reduce energy consumption by only running the heat lamp when it is needed. A third way to conserve energy is to insulate the well house. Insulation helps to prevent heat loss, which reduces the amount of energy needed to heat the well house. Now let's address some common problems with heat lamps. One common problem is that the heat lamp burns out prematurely. This can be caused by using the wrong wattage bulb, using a faulty bulb, or having loose wiring connections. Another common problem is that the heat lamp does not produce enough heat. This can be caused by using a low wattage bulb, having a dirty reflector, or having poor insulation in the well house. A third common problem is that the heat lamp trips the circuit breaker. This can be caused by using a high wattage bulb, having a short circuit in the wiring, or having a faulty heat lamp. When troubleshooting heat lamp problems, always disconnect the power first. This will help to prevent electrical shock. Use a multimeter to check for voltage and continuity. Consult with a qualified electrician if you are not comfortable troubleshooting electrical problems. Now, let's talk about the importance of regular inspections. Regular inspections can help to identify potential problems before they become serious. Inspections should include checking the wiring for any signs of damage, checking the heat lamp for proper operation, and checking the well house for any leaks or other hazards. Inspections should be performed at least once a year, or more often if the well house is located in a harsh environment. Keep a record of all inspections and any repairs that are performed. Also, remember the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or building contractor before performing any electrical work. Comply with all applicable codes and regulations.